Yeah, now it's okay. ठीक है. So for an angle section, wait. Yes. Now see over here, the bolts are actually connected in this manner. For this case, huh? For this particular case, the bolts are arranged in this manner. So what I am doing, I am looking at this figure from here, isn't it? So these are the two bolts. Okay, that is this bolt, but there is a row of bolt. Okay, along this direction, direction. Now see what happens over here. What it states, what is ATN? ATN is nothing but the net area in tension from the bolt hole to the toe of the angle. Okay, what is the toe of an angle? So this portion is known as the toe of an angle, and this portion is heel. Am I right? This will be heel. Okay. So remember, whatever ATN value that has been defined by the IS code for angle section, it is this distance. This distance. That one has to remember. It is not this distance. That is from here to here. ये नहीं है. Got it? This is not that ATN distance. This is very particularly from this point, that is the from the bolt hole to the toe of the angle. Had that arrangement been over here, something of this sort, then this distance of ATN would have been from here to here. Is this clear? Is this okay? ठीक है? तो ये जो distance है, how to calculate ATN and all that we will be discussing. But while calculating ATN, one has to keep this point in mind, that distance shall start from here to here. That is the toe part, up to the toe part, not to the heel part. Am I right? ठीक है? Right. So fine. So next part is let's see what is the behavior of an angle section which will be subjected to tension force, and if bolted connections are provided. In that case, how is the failure pattern? There are two types. This is block shear 1 failure, and this is shear 2 failure pattern. So you can see for failure 1 type, the load is getting applied. You can see there are actually three figures. Okay, for this is the same experiment, but the views are different. ये जो है ये side view है, this is plan, and this is three-dimensional view of the same experimental setup. Okay, force is getting applied. Now just see with the increase in the force value, what is the behavior that we need to observe. ठीक है? Now see, can you see there are two planes. ये जो है एक, this is one plane of failure and this is another failure plane, isn't it? Correct? Over here, with the increment in the load, same experimental setup, but three different views, you can say. what happened. Okay, now the force is getting applied. Now you can see. Okay, again there are two planes of failure. One was this, and if you have observed, the failure that is in the perpendicular direction, that was from the toe. Okay, isn't it? That started from the toe portion of the angle section, and the shear plane is like this only. Over here also the shear plane is like this. Okay, but the weaker plane, you can assume this to be the weaker plane. In this weaker plane, it started from the toe portion of the angle section, right? So in both the cases, you must have observed that the failure, it occurred from the toe portion of the angle section. So there are only definite two sections. This one be the first, and this will be the second failure plane. Okay, so this was what it was with respect to the angle section, typical angle section, right? For plate sections, as IS code has specified, there are three planes, three failure planes. This is one, second, and third. Okay, description can be seen over here. Similarly, for this thing, the description can be seen over here. Okay. Now there is one concept which is known as the effective net area. For angles, those are connected through one leg of the element. The net area obtained will be reduced, which is called as the effective net area. This effective net area, it comprises of these coefficients, which are K1, K2, K3, and K4. These are the multiplying factors, or we can also call them to be some coefficients which governs the net area value. Because you can see, since the presence of the bolt hole is there, and when this bolt hole portion, when it will come in contact with the bolt, in that case, what will be the changes? What will be the changes in stresses? That one has to take care of. So in order, this point has been well taken care by the IS code, and you will see that this net area value, whatever has been defined in the IS code, you will all the time you will come across this term which is known as the net area, which is also known as the effective net area. The background for this effective net area can be seen in this description. What is this A and E? It is nothing but these coefficients into the net area, right? So let us try to understand what are these coefficients. K1 is known as the ductility factor. What it says, that the net section strength of a tension member increases with ductility of steel. As you know, that steel is a ductile material. So the net section strength, or the capacity of that net section, whatever hole we have provided for insertion of the bolt, that capacity will increase with the ductility of the steel. This is due to the stress concentrations at the bolt holes are better distributed over the section when steel is in plastic state. Okay, so we have seen the figure associated to the stress distribution in the plastic state. So if you remember, if this is the bolt hole in plastic state, the distribution is very much like this, over here as well as over here, isn't it? So it is more or less uniform, you can understand. Okay, so therefore, for ductile materials, this value is considered to be 1. So K1, since steel being ductile material, and at ultimate stress, this stress distribution is almost uniform. So therefore, this value is assumed to be 1. Second is K2 factor. This is known as factor for method of fabrication. Depending on the type of process of fabrication, the whole formation जो होता है, it may be drilled, it may be flame cut. Okay, so depending on all these fabrication methods, IS code has provided this K2 value. This is known as hole forming factor also. So holes are formed either by drilling or punching. As per IS 800, increase hole diameter by 2 mm for punched holes, and K2 is equal to 1 for drilled holes. This has been already introduced. Okay? So most of the time you will see that the hole diameter is almost 2 mm additional. So the clearance, as mentioned in your IS 800, is about 2 mm. But for punch holes, you will see this K2 factor is 1. Okay? Then geometry factor. This K3 is known as geometry factor. So efficiency of the bolt joints is inversely proportional to the gauge to diameter ratio. Okay, this value is generally between 0.9, 0.9 to 1.14. But IS 800 2007 it specifies this value to be 1 only. Okay. The thing is, this, if this is the connection, let's say these are let's say 2 plates like this, and they are connected with the help of bolts in this manner. Okay. What it says, the efficiency of such kind of connection is inversely proportional to the gauge to the diameter ratio. Okay, so the gauge distance to the diameter of the whole ratio. Okay. So various other IS codes have identified this value to be between 0.9 to 1.14. Not IS codes, sorry, by mistake. Various other standard codes like the Euro code, British code, Australian code, etc. They have identified this value ranging between 0.9 to 1.14. Okay. Whereas our IS code has converted that value to 1. So again, what you can say, K3 value is 1. As far as K2 value is concerned, it is nothing but the clearance, which has been represented in one of the tables. Can you remember what is the table number for identifying the clearance value for bolt holes? Do you remember that table number? Right. So that has to be used in order to find out this. Actually K2 जो है वो उस क्राइटेरिया में कवर हो जाता है. ठीक है. So even if you don't consider this K2 value in this equation, well and good. K1 is 1. Now K3 is 1. K2 is taken care by that formulation or by that clause. Let us see about K4. What is K4? This is very important. K4 is known as shear lag, coefficient pertaining to shear lag. So what is this shear lag? Shear lag is if such kind of connection if you observe, okay, and very specifically I'm talking about the angle section. This is all for angle section. When such angle is connected to some another member, what happens? It has been experimentally observed that the stresses distribution is something of this sort. At the portion where connection is done with the help of bolts or weld, whatever it may be, the stresses are uniformly distributed. However, this leg which is not connected, which is also known as outstand, this is also known as outstand. So if for this portion you will see the stress variation is something of this sort, which is non-uniform. And this non-uniformity, as you can see from this figure, the portion of non-uniform distribution, it is from, let's say, this point to this point. This is known as transition zone, you can say. Why? Because in transition zone, these stresses they lag. That is, some delay is observed for the stress to become uniform from non-uniform pattern. ठीक है? तो यहाँ से यहाँ तक it is non-uniform and there is some delay. And after that delay, you will see all the stresses are uniformly distributed. Okay, so this is known as what you can say. This concept is known as shear lag. There is lag in the stresses. This is known as shear lag, which is defined as K4, which is given by this formula 1 minus x bar by L. X bar is nothing but this centroidal distance as mentioned over here in this figure. Okay? This is the outstand, this is the connected leg, right? And this x bar is this much distance. L is known as the connected length, connection length, you can say. And this connection length formulation is mentioned in your IS code, right? That we will see. So obviously, since based on this equation, L, this connection length is most of the time is greater, always greater than this x bar value, and therefore you will see this value is always less than 1. K4 should be less than or equal to 0.9. This is what is specified in your IS code. Okay? For angle section, 0.6 for 1 or 2 bolts. If there are 1 or 2 bolts, this shear lag, which is represented by alpha in your IS code, should be 0.6, 0.7 for 3 bolts, and 0.8 for 4 or more bolts along the length in the end connection or equivalent weld length. So even for welding, okay, this alpha value has to be defined. So since weld is, most of the time weld is provided throughout the connection part. So from here to here, here to here. Therefore, you will find that the connected length is always more, and hence this alpha value for weld length is given as 0.8. Okay? So the net area, net effective area for this connection or the bolt hole, as per IS code, it uses all these coefficients, that is K1, K2, K3, K4, and this AN is what you can say theoretical net area, whatever we calculate. Okay? But this theoretical net area should comprise of all these coefficients, those are multiplied to it, so that we will get a logical effective net area. Got it? Okay? So we will understand, we will try to utilize all these values when we will cover the numerical part. So let us begin with the numerical part and let us try to understand how whatever we have studied till now, what we have studied, we have studied the calculation of VDSB, VDPB, that is the capacity of the bolt. Then also we have also covered the net section, net rupture section capacity of the plate. We have also seen the tension capacity of the bolt, the combined effect of tension and shear on the bolt, and the connection as a whole, isn't it? Now let us try to utilize this knowledge of modes of failure, whatever we have learned. What are those? The first is the gross section yielding, second is the net section rupture, and third is the block shear failure. Let us try to utilize this concept and verify whether the design, whatever design we are providing, that is safe or not. Okay? In that, you will also come across the concept of net area value, effective net area rather, effective net area, A and E. Tick. So let us start. So I hope you people are having the notebook, pen, calculator along with you, and also please open the IS 800 2007. Tick. One more thing. Oh, few things are to be referred from steel table. Okay, steel table or IS 808 1989. Steel steel table. Steel table. You will get the steel table from the market. You can purchase it, uh, or you can even make use of the IS 808 1989. This can you can easily download from the internet. Okay, you can make use of either of this. Steel in steel table, you will find that there are various other parameters which may be useful, right? It is authored by Ramamrutham. You can get it, you can purchase that. But for today's class, you can download IS 808 simultaneously, and you can see I have also provided a few things for your convenience. You can refer it later on. But from today, from the next class onwards, you please make sure that you should have either steel table or IS 808 1989. One more thing I would like to tell you that there is some very minor difference in the values with respect to steel table and IS 808. So it won't matter much. You can refer, you can consider the values from either steel table or IS 808. Doesn't matter. But whenever you are referring the values, you are supposed to mention that this value has been considered from steel table or IS 808, whatever it may be. Okay? So let us begin with this small numerical and let us see the application of all the or the modes of failure, whatever we have learned. So fine. This numerical, it says determine the tensile capacity of sections as shown in figure. What you are supposed to check? Tensile capacity. If the angles are placed on opposite sides of gusset plate with the help of tack bolting, if the angles are placed on same sides of the gusset plate, again with the help of tack bolting, is there any problem? Okay, I will continue. And if the angles are not tack bolted, fine. The bolt grade is 4.6, plate grade is given as FE410. What is tag bolting? Tag bolting is very simple. It is nothing that when two members are to be connected or considered as a homogeneous unit or one unit, the bolts provided are known as tag bolts. Connections are made accordingly. Okay? Now see, let us consider the case 1. What it says, that angles are placed on opposite sides of the gusset plate. The gusset plate dimension and other information, this is given in this figure. So just try to understand how the angles are connected with the help of gusset plate when they are placed on the opposite sides of this gusset plate. So as you can see over here, this is one angle, this is second angle, and they are on the two sides of this gusset plate. Okay, I hope you have understood this thing. So it is something of this sort. This is the gusset plate. Sorry, gusset plate is like this straight, and to the gusset plate, this is one angle like this, and second angle section, which will start from certain distance, which is nothing but the thickness. Okay, it will start from here, something of this sort. It is like this. Okay, and this will be the second outstand. So are you able to understand what I have drawn over here? This is one angle section, and this is second angle section on that side. That is, you can consider this one, right? And these are connected with the help of bolts over here. यहाँ पे एक bolt नहीं है, यहाँ पे there are more number of bolts, something of this sort. So the information is given to be this representation. As you can see, this is double angle. ISA का मतलब होता है Indian Standard Angle. Double Indian Standard Angle. The dimension is 90 by 60 by 8. What does this stand for? 90 is one of the leg dimensions, 60 is another leg dimension, and 8 is the thickness of the angle section. ठीक है? And in this, it is considered that the longer leg, this is longer leg because the dimension is more compared to the second leg. So the longer leg is connected to the gusset plate. This is what is given. Okay, and 8 mm is the thickness. The thickness of the gusset plate is 12 mm. This is again given. Then the pitch of the bolts, this is mentioned as 40 mm. Then the edge distance is mentioned as 30 mm, that is this distance. And the number of bolts, there are 6. So you can imagine there are 6 number of bolts in this connection like this, and they are connected in one single row, you can say. Okay? From the side view, that is from here, this will look like this. Okay? Fine. These are known as unequal angle. Sometimes it is also known as unequal leg angles. Unequal in the sense, this dimension and this dimension, they are not same. So by that mean, you can consider there may be equal angle sections also. Yes, there are. So you will find in the steel table or in this IS 808, there are equal angle and unequal angle specifications which are mentioned. So as you can see over here, this is I have considered from IS 808. This angle section, there are some terminologies, you can say. This is AB, long leg, short leg. This is curved portion, wherein you will find there is some root radius associated to it. And over here, as you can see again, this portion is curved. This is known as toe radius. So we have discussed this portion is known as toe. and this is known as the heel portion of the. It is just like our foot or feet, right? This forms the heel, and this forms the toe. Is this okay? Right? So this is the given information, and now with respect to this given information, we are supposed to determine the tensile capacity of the section. So let us begin. Before that, before calculating the tensile capacity, let us first of all find out few parameters. First is the gross area, and what we will do is, instead of calculating the parameters associated with both the angles, let us go step by step. Let us first of all consider one angle, and since it is one unit, it can be multiplied by 2 later on, and we can find out the associated values. Okay. So first of all, let us find out AG. AG is the gross area of this angle section. Single angle section we will consider. As per IS 808, and this table number 6.1 I have given. This is for IS code. For steel table, the table number will be different. Okay, that you can refer. So you can see ISA 90 by 60 by 8. The gross area is mentioned as 1140 mm square. This is what is given. Okay. Then, therefore, the gross area for double angle section, it will be twice of this. Okay. Next is, we need to find out the net area, AN. So this net area is as per the geometry of this figure. Right now, it won't consider the, what you can say, the K1, K3, K4 parameters. It will consider K2 parameter. K2 parameter क्या है? Clearance का. Okay. And as per IS code, IS 800, the clearance value can be found from that table 5, which you have told me. And for 16 mm diameter bolt, what will be the clearance? What is the clearance? Already I have mentioned over here, but just you can verify. Is it 2 mm? Is it 2 mm? Yes. Yes. Is the clearance 2 mm for 16 mm bolt? Please let me know. And therefore, you will see while calculating the AN value, AN is nothing but the summation of the net areas of the longer leg and the shorter leg. Okay? So you can see the deduction part has to be considered. So ये देखो ये 90 mm total distance है from this point to this point. But for calculating the net area, we are supposed to consider the center lines. So as I've drawn the center lines like this distance for the longer leg will start from this point and will be up to the center line of this position. So whatever I have written, 90 minus 18, ठीक है, 18 क्यों 18 आएगा? Because the bolt hole will be 2 mm more than the bolt diameter. So clearance is 18 mm minus 8 by 2, because I have drawn the center line of this. So the thickness of this member and as well as this member, it is 8 mm. So it has been reduced. I hope you have understood this thing. Correct? Similarly, for 60 mm dimension, this is the center line, and with respect to this center line, since this dimension is 8 mm, this will become 60 minus 8 by 2. बराबर है? And the net area shall be this plus this. Since there are two angles, therefore the complete net area shall be multiplied by 2. Is this okay? I hope this is understood. This is very simple to understand, right? Now this next part is to calculate the design strength due to gross yielding. This is required है ना. जैसे हमने देखा ना, 3 modes of failure: gross yielding, net section rupture and block shear. First design capacity will be with respect to this TDG. I have not written the clause number and all. It is your responsibility to write down the clause number and page number for this formula. Okay, that has to be completed, right? So Ag into Fy divided by gamma m naught. From where you have calculated, or from where do you get the gamma m naught value? That table number has to be mentioned. Table number, page number. Am I right? That needs to be mentioned. ठीक. From that you will get this some value for TDG. अच्छा, Fy. ये जो Fy value है, sorry, what happened? Wait, there is some problem. Okay, this Fy value, from where will you get this Fy value? This is for the angle section or the material. कहाँ से मिलेगा Fy value? I have written it to be 250. Why I must have written it 250? And why it is 250 only? Why not some other value? What does Fy stands for? It is yield stress, and since we are concerned with the yield stress of this angle section, which is nothing but steel member, material property steel, you please verify table 1 of IS 800 2007. So you please check that. And where do you find out this 250 value? For grade, I will give you hint. This is for grade 410. Okay, for grade 410, where do you observe this 250 value to be written? वो आप identify करो. ठीक है? So in the next class we will discuss from where do we get this 250 value and why we have considered 250 value only. That we will be discussing, and then we will proceed for the latter part of discussion, that is design strength due to net rupture and the block shear failure and all. ठीक है? So I please you find out this value of 250. From where do we get the 250 value? Will you do that? Yes?
Yes, sir.
Okay, fine. So in the next class, that is tomorrow's class, please let me know from where to get this 250 value. I will stop over here. I hope you have understood the today's explanation. In case of any difficulty, you can ask me later on. ठीक है? So thank you.
Yes, sir.
You